Right, so the collision theory is a very common set of questions that come up nearly every year, and it focuses on the four different variables that can affect the speed of the reaction, of any reaction. Right, so let's look at temperature to start off with. So how does temperature affect the speed of a reaction? Now, if the question is asking you to describe how, you need to always say that if you increase temperature, rate of reaction will increase. If you decrease temperature, rate of reaction will decrease. So I'm just going to focus on one of them. So increasing temperature. Increasing temp increases the speed of a reaction. Now that's quite an obvious statement, but often students miss that out and miss out a mark. So that, unless they tell you this, you will obviously get a mark. Now the reason why that is the explanation. So when particles have an increase in temperature, particles will gain more kinetic energy. So they'll gain more kinetic energy, so that's important to remember. And this will increase the frequency of successful collision. Okay, now this frequency is really important. If you don't use that word, you often don't get the mark. You've got to talk about the frequency, or the fact that there's an increase collision per second, but frequency is an easier term to use to describe that. So that's usually a 3 marker. Increasing temperature speeds up the reaction, more kinetic energy, more frequent successful collision, faster rate of reaction. Now the other variable, concentration stroke pressure. Concentration if we're talking about solutions, pressure if we're talking about gas. So again, I'm just going to focus on one of them. So increasing concentration increases the speed of a reaction. Explaining why, when there is an increased concentration, there are more particles. Now this could be say an acid, so you then say more acid particles. If we're talking about a gas, you might then say more gas particles. So there are more particles in a given volume. Now that is crucial that you say in a given volume, because you can increase the number of particles, but if your volume also increases, then the concentration doesn't necessarily increase. So more particles in a given volume, this will increase the frequency of successful collision and therefore faster rate of reaction. So again, frequency is an easy term to use to describe that. Okay, so that's again 3 mark, really straightforward, comes up every year. It's worth reviewing that. The third variable we'll look at is surface area. So surface area, first of all, you need to just recognize the fact that the smaller the particles or substances, the larger the surface area. Now that's sometimes quite difficult to sort of comprehend really. If you think about it, loose sugar, you've got small substances, small particles, they dissolve in tea much quicker than a sugar cube. So when you cut an onion up, the main purpose of cutting it up into smaller bits is so that it cooks quicker, because it increases surface area. So the point of cutting something is to increase surface area. So the smaller the substance, the larger the surface area. So that's the first thing that you need to get your sort of head around. And then just recognizing that bigger surface area, so bigger surface area speeds up the rate of reaction. And the reason why that is there are more exposed area for particles to react with. You can even do it through calculation. If you think about a cube, say you've got a cube, a 2 by 2 by 2 cube, that will have a surface area. So if it's a 1 centimeter, so 2 by 2 by 2, that will give you a surface area of 4, and the 6 sides to a cube, so 4 times 6, 24 centimeters squared. Now if you then take this cube up and break up into the small units that it's made of, you'll end up with a cube like that, but for 8 of them. So you've got 8, and each side is 1 by 1 by 1, so you've got 6 sides. So 6 times 8, which is 48 centimeters squared. So you can see that by making a substance, making this cube smaller, what you're doing is you're drastically increasing the surface area of that substance. Okay, so that's the third variable. And the fourth one is a catalyst. So a catalyst, the presence of a catalyst. So presence of a catalyst increases the rate of reaction. Transition metal, often if they ask you what transition metals are used for, catalyst is a good example to say. If you think about there's iron and platinum that can be used as a catalyst. Now the way it does it is catalysts reduce activation energy. Now remember, activation energy is the minimum energy needed for a reaction to happen. So what a catalyst does is it reduces it so that you need less energy, which means more particles can exceed the activation energy, and more particles can exceed the activation energy and cause a reaction. Exceed the activation energy. Okay. And react. A good way is to think about it is if your entry requirement is to get into university is reduced from 3 A stars to 3 Bs, more students will be able to exceed that requirement compared to when it was much higher. So reducing the requirement, so reducing the activation energy, means that more particles can exceed that, and therefore the reaction happens quicker. So those are your 4 variables that will affect the speed of a reaction.